Hello students, today we are going to see electromagnetic waves. Before we enter in the lesson, let us see the introduction of this lesson. We see the world around us with the help of light. The light doing little role to see the worlds and also understanding the from atom to universe. That means with the help of light we can understand the structure of from atom to the universe. What is light? This question made scientists sleepless during 19th century. Then middle of 19th century, James Clerk Maxwell, scientist, came and he gave theoretical explanation. That means light is an electromagnetic wave which is travel with 3 to the power 8 meter per second speed, and the latter that light is only a small portion of electromagnetic spectrum, and also his theoretical prediction is that magnetic field is induces during change of electric field. Now we see that electromagnetic field. That is, lesson is electromagnetic waves. Magnetic waves. This is the produce. Electromagnetic waves. Now we see the first topic of electromagnetic waves. That is displacement current. Displacement current. What is meant by displacement current? Before entering this, we know that according to the electromagnetic induction, time varying magnetic field produces an electric field. We can see this in mathematically. Close integral E vector into dl vector is equal to minus d by dt phi d is equal to minus of d by dt close integral d vector into dl vector. Electric field is induced along the closed loop by changing the time varying magnetic field. See the derivative. The electric field is induced by changing the magnetic flux. So time varying magnetic flux induces the electric field. And James Clerk Maxwell asked that converse of this derivative. We will see the converse of this derivative. Close integral d vector dl vector is equal to minus d by dt phi e is equal to minus of d by dt close integral d vector into dA vector. What we understand from this derivative? Magnetic field is produced by changing the electric field. That means time varying electric field enclose the loop which produce magnetic field in the loop. So this derivatives converse of this derivative. Now we have to understand that time varying electric field produces magnetic field. How can we understand this? We can understand this concept with the help of a practical, for which we should take a parallel plate capacitor. Now we are going to see how changing, that means time varying electric field produces magnetic field. Let us see. For this, we should take a parallel plate capacitor. See the parallel plate capacitor having there are two plates. Parallel plate capacitor. This is the diagram for parallel plate capacitor. This is positive charge carrying plate, negative charge carrying plate. This is the positive negative. value. Now, current flow through the capacitor which produces IC current. IC current produces magnetic field around the wire of the capacitor. If you bring the magnetic field and place it near to the wire, we can understand that the magnetic field is produced due to IC current. So now we are going to measure the magnetic field, strength of the magnetic field at any point on the wire. Suppose I have to find out that magnetic field at point P. I have to find out magnetic field at point P. That means strength of the magnetic field. So I have to follow Ampere's circuit law. What is Ampere's circuit law? The Ampere's circuit law says that the line integral of magnetic field around any closed loop is equal to mu naught times the net current flowing through area enclosed by the loop, which you can say in mathematically, that is, in mathematically it can be like that. Closed integral d vector dl vector is equal to mu naught times the net current, mu naught times the net current flowing through the enclosed by the circuit. Closed integral d vector dl vector is equal to mu naught times the net current flowing through the enclosed circle. Here time is given, magnetic field is varying with respect to time. We have to find out magnetic field point P, for which we have to follow Ampere's circuit law. So, Ampere's circuit law, that is, we have to follow Amperean path. I will draw a circle around the point. This loop produces a surface that is called S1. S1 is the surface followed by the Amperean loop. So, for which I will take mathematical form, closed integral d vector dl vector is equal to mu naught times the IC current flow to the capacitor. That means IC is the conduction current flowing through the wire. Suppose this Ampere loop enclosed by balloon shaped surface. That means S1 is the circle surface, S2 is the balloon shaped surface. I have to find out the magnetic field point P. Here, the balloon shaped surface separate the capacitor plate from a positive plate separated from the negative plate. So there is no current flow this S2 surface. So at this point, that is magnetic field will be 0. That is magnetic field will be 0. That means the right hand side of this derivative will be 0. That is closed integral d vector dl vector is equal to 0. Because this S2 surface does not accept the current flowing IC. So the right hand side of the derivative will be 0. So see the derivative number 1 and derivative number 2. Derivative number 1 says that closed integral d vector is equal to mu naught IC. Here closed integral d vector dl vector is equal to 0. These two derivatives have different concepts, that means inconsistency. So the inconsistency solved by Mr. James Maxwell. That means the battery produces current through the capacitor. That means due to this example battery, the capacitor will be gets charged. Due to this current, the charge will be an electric field will be set up between the plates of the capacitor. So there is a current associated with the charge between the capacitor plates. that current is called displacement current. According to Gauss law, electric flux between the two plates of a capacitor phi E is equal to closed integral of E vector into dA vector is equal to EA is equal to Q by epsilon naught. This is the electric flux between the two plates of a capacitor. What is the electric flux changes between the two plates of a capacitor? Change in electric flux. Change in electric flux will be d phi E by dt is equal to d phi E by dt is equal to 1 by epsilon naught dq by dt. We know that dq by dt means id is equal to epsilon naught d phi E by dt. What is the d phi by dt? Electrical changes with respect to time, and what is epsilon naught dq by dt? dq by dt means displacement current. Now, displacement current is equal to epsilon naught d phi by dt. This is the flux changes with respect to time between the two plates of a capacitor. What is meant by displacement current? Whenever the electric field changes with respect to time, a displacement current is produced. So, Maxwell modified the Ampere circuit law. What is meant by Ampere circuit law? Closed integral B vector d vector is equal to mu naught I. So, closed integral B vector dl vector is equal to mu naught I. Here, I is equal to that is mu naught IC plus ID. That is closed integral B vector dl vector. So Maxwell modified the Ampere circuit law like this. So here I is equal to IC plus ID. I is the total current. I is the total current. Encloses the closed loop. I is the conduction current. I is the displacement current. Suppose if constant current flows to the wire, that is ID will be zero. Now total current will be ID is equal to IC. This is called displacement current. Suppose where current is close, now IC is equal to ID. I is equal to ID. Then
Maxwell's equation in integral form. Electrodynamics can be summarized into four basic equations known as Maxwell's equations. It is same as that of Newton's equation in mechanics. Maxwell equations completely explain the behavior of charges, currents and properties of electric and magnetic fields. This equation can be written in integral form. The differential form of Maxwell equation is beyond higher secondary level because we need to learn additional mathematical operations like curl of vector and a divergence of vector. So we focus here only in integral form of Maxwell's equations. First equations is nothing but its Gauss law. It relates the net electric flux to net electric charge enclosed in a surface. Mathematically it expressed as closed integral E vector dA vector is equal to Q enclosed by epsilon naught. Here E is the electric field and Q is the enclosed charge. This equation is true for both the discrete and the continuous distribution of charges. It also indicates that electric field lines start from positive charge and terminate negative charge. This implies that the electric field lines do not form a continuous closed path. In other words, it means that isolated positive charge or negative charge can exist. That means positive charge can exist and negative charge also can exist individually. And also the electric field lines do not form a closed path. This is indicated by the first equations. Second equations, no name, but this law is similar to Gauss law in electrostatics. So this can also be called in Gauss law magnetism. The surface integral of magnetic field over a closed surface is 0. Mathematically, closed integral B vector dA vector is equal to 0. B is the magnetic field. This equation implies that magnetic lines of force forms a continuous closed path. In other words, it means that no isolated magnetic monopoles existed. That means no north pole existed, no south pole existed. Third equation is Faraday's laws of electromagnetic induction. This law led the electric field with the changing magnetic flux, which is mathematically written as closed integral E vector dl vector is equal to minus d phi by dt. Where E is the electric field, this equation implies that line integral of electric field around any closed path is equal to the rate of change of magnetic flux through the closed path bound by the surface. Our modern technological revolution is due to the Faraday's laws of electromagnetic induction. The electric energy supplied to our homes from electricity board by using the Faraday's laws of induction. The final and fourth equation is modified Ampere circuit law. This is known as Ampere-Maxwell's law. This law led the magnetic field around any closed path to the conduction current and the displacement current through that path. That means closed integral B vector dl vector is equal to mu naught I enclosed plus mu naught epsilon naught dy by dt closed integral E vector dA vector. Where B is the magnetic field, this equation shows that both conduction and also displacement current produces magnetic field. These four equations known as Maxwell's equation in electrodynamics. This equation ensures the existence of electromagnetic waves. The entire communication system in the world depends on electromagnetic waves. In fact, our understanding of stars, galaxy, planets, etc. come by the analyzing the electromagnetic waves emitted by these astronomical objects. Thank you. We'll see next class.